inverted symbol of union B is equal to X such that X belongs to A and X belongs to B. Very important here, the statement and. Very, very important. So let's see. I'll explain why that word and is important. But before that, let's see how we can describe that A intersection B in the Venn diagram. Okay? Let's see. This is the set A. And this is the set B. Now A intersection B is actually this region. Okay? Now, if I take this example that A is equal to 1, 2, 3 and B equal to 2, 3, 5, what will be A intersection B? This region, that means what is there in this region? That is 2 and 3. So, A intersection B will be, for this example, A intersection B will be 2 and 3. Now that we established by means of Venn diagram. Now how we can establish the same thing by means of this set builder form definition? Now let's take A equal to 1. 1 belongs to A but not to B. That means 1 belongs to A and 1 belongs to B. That statement doesn't hold true. That's why 1 is not part of A intersection B. 2 belongs to A and also 2 belongs to B. So that means 2 belongs to A and 2 belongs to B. That statement holds true. Correct? That's why we put 2 as an element in the set A intersection B. Similar for 3, similar logic for 3. 3 belongs to A and 3 belongs to B both. So hence 3 is an element of the set A intersection B. But 5 belongs to B, but 5 doesn't belong to A. So 5 belongs to A and 5 belongs to B. That statement doesn't hold true because AND is there. Right? So now you understood, in case of union OR and in case of intersection AND, why it is important. The more importance of these two words OR and AND will come later in the set, and later when you will discuss about the permutation combination, there also you will find that why OR and AND are so important. OR actually represent in that case the principle of addition and AND represent the principle of multiplication. We will discuss in great detail when we will discuss about permutation and combination. Now let's come to the complement. So this part about the union, okay, this part about the intersection. Now, what is a complement? Okay. We can describe it like a complement. Complement is that is, suppose complement is actually applied on a single set. In case of union and intersection, you saw that there are two sets required, right? So it is a kind of a binary operation. That means there are two operands and one operator. What are the two operands? A and B. And what is the operator? Union and intersection. But in case of complement, it is a unary operation. That means, sorry, it needs only one operand, okay, and that operand in this case is the set A, and its complement is denoted by either A bar or A prime. What is the definition? So A bar or A prime is equal to X such that X doesn't belongs to A. Clear? Here it is X such that X doesn't belongs to A. Now, how it is meaningful? Let's take the previous example. A equal to 1, 2 and 3. How we can construct A prime or A bar? Is element X where X doesn't belongs to A. We know that A bar should not contain 1, 2, 3. But what it should contain? That also you do not know so far, right? So there is a concept called universal set. Universal set conceptually is a set which is a superset of all the sets what you can think of. And in Venn diagram, the universal set is described in a rectangle. All the other sets are in circular form, but the universal set in a rectangle. So the moment complement is coming into the picture, we need to define what is the universal set, okay, with respect to the set A. Let's take an example so that it will be more clear and we can compute A bar. Let's take the universal set U is equal to, universal set by the way generally defines as U is equal to 0, 1, 2, 3, 4. So if we describe in Venn diagram how it looks like, as I said, universal set in Venn diagram described in a rectangle. So it will be 0, 1, 2, 3, 4. That is the universal set U. Now the set A is 1, 2, 3. That is the set A 1, 2, 3. That is the set A. Now what is A prime? A prime is the set contains elements which doesn't belongs to A. What are the elements left? 0 and 4, right? So A prime will be 0 and 4. Obviously, one important thing is that if you make A union ever, what you will get? You will get the entire universal set. So what is the conclusion? A union ever is the universal set. And if you make A intersection ever, nothing, there is no element. There is no element which belongs to A intersection ever. So what is that set which contains no element? We remember we have discussed about it. It is called empty set. So A intersection ever is equal to phi. The empty set which is described as phi. So we see how complements work. Okay. So this is a region where we discussed about the complements. Okay. So what I will suggest, please have a detailed look about these three operations, union, intersection and complement clearly. Spend 2 minutes. After that we will come to the next discussion. Welcome back, students. Now we are going to discuss something different. And that is called the properties, or more precisely to say, it is called the algebraic properties. Algebraic properties. Property applied to what? Property applied to the operations. So, what are the operations we have seen so far? Union, intersection and complement. Now we are going to discuss the algebraic properties on union and intersection. Okay? So, our topic is that algebraic properties of union and intersection. The first property is called consistency property. What is that? Let's take two sets, A and B. Okay, in such that B is a subset of A. Let's take two sets, A and B, such that B is a subset of A. Now, from this information, you can infer two other information. What are the two other information? Is that A union B will be what? If B is a subset of A, then A union B will be A. Why? Because all the elements of B are the elements of A. So that means A union B equal to A. Okay? Do you want me to show by means of Venn diagram? Okay, let's have a very quick look. Here Venn diagram will be very helpful. Let's see. Suppose this is the set A and this is the set B. Obviously, because all the elements of B are the elements of A, so B should be inside A in the circular form. So now, if you take the union of A and B, it should be the interregion, which is nothing but A. And another property here is that A intersection B is equal to B. You have to see by means of the Venn diagram. Let's have a look into it. Suppose this is A and this is B. Now A intersection B means those elements which belongs to A and B, right? So that means it is only these elements which belongs to both A and B, which is nothing but the set B. Now let's come back to the why it is consistent. It is consistent that these three properties are consistent to each other. That means if you know if any of the property holds true, the other two properties actually follow. What does it mean? It means that if B is a subset of A, you can conclude, okay, A union B equal to A and A intersection B equal to B. If someone tells that A union B equal to A, you can infer the other two properties, that B is a subset of A and A intersection B equal to B. And the other one, the third one, if A intersection B is equal to B holds true, you can infer the other two properties, other two equality also holds true. So not equality, other two properties also hold true. It is B is a subset of A and A union B equal to A. So as one property actually implies the other two properties, that's why it is known as consistency property. Next one, we are going to show the commutative property. Okay. So let's take two sets, A and B. Okay. Now the commutative property tells that A union B is equal to B union A, and A intersection B is equal to B intersection A. Clear? Okay. So here we have discussed about the consistency property. Here we discussed about commutative property. Next one we are going to discuss is called associative property. Okay. For associative property, we need three sets. Let's take those three sets are A, B and C. Okay. A, B and C. These are the three different sets. Then the associative property tells that A union B union C is equal to A union B union C, and A intersection B intersection C is equal to A intersection B intersection C. That is called associative property. You can prove all this property by your own. In case of any doubt, you can contact me later. So this is called associative property. The next and the last property is called distributive property. Okay, what is distributive property? Let's have a look. So like associative property, here also we need three sets, A, B and C. So let's take three sets, A, B and C. The distributive property tells that A union B intersection C is equal to A union B intersection A union C. And the other way, A intersection B union C is equal to A intersection B union A intersection C. Notice very carefully. Here there is one union operation, one intersection operation. But the result of this one is that there are two union operations, this one and one intersection operation. So that means the union is getting distributed. Here the other thing. Here is one in the left hand side, there is one intersection and one union operated. Now in the right hand side we see there are two intersections and one union. That means in this case intersection is getting distributed over union. In the first case the union is getting distributed over intersection. So it is getting distributed, that is why it is known as distributive property. I am going to close the class today here. Our next class, I'll start from here and we'll proceed further. Meanwhile, in case you have any smallest doubt, please contact me, and here is my contact information. I'm writing it here. KonarClasses